All right, the rationals. Okay, so every natural number is also a whole number. Which is to say that if n is an element of the set of natural numbers, so just a bit of set notation here, that would imply that it is also an element of the set of whole numbers, right? Okay. We also write this idea in a sort of more condensed set notation form as follows. Set of natural numbers is a subset of the set of whole numbers. All right. Similarly, we might say if a number is an element, if a number w is an element of the set of whole numbers, then w is also an element of a set of integers. All right. So let's introduce the notion of a rational number to characterize any number that is the ratio of two integers. All right? All right, so that's a sort of standard way, let's say, of introducing the notion of a rational number as a number that is the ratio of two integers. Definition 6. The set of rational numbers. All right, so the set of rational numbers, which is typically designated as or by double struct capital Q, Q standing for quotients, all right, is the set of all such ratios m over n such that m and n are integers, and n does not equal 0. Great. Okay. The n not equaling 0 restriction is required as division by zeros undefined. All right. Okay, so the set, and then let's just now go over some examples of rational numbers that are sort of constructible based on this definition that we have so far and the sort of preluding logic. Okay, so the set A over B, comma, quantity A plus 1 over B, comma, minus A over B, containing ratios of integers is a set of rational numbers is a set of rational numbers. Now, arithmetically, we may consider integers like 6, elements of correlative sets of synonymous rational numbers Okay, so correlative sets of rational numbers. We'll see what I mean by that in just a moment. All right, such as okay, so what do I mean by this phrase, correlative sets? Correlative sets of synonymous rational numbers. Okay, so arithmetically, right, basically the idea is that all of these evaluate to the number 6, right? So we've got a few more that I can add in here, actually. Okay, and so there are essentially infinitely many of these. So it's a set of correlative values. They all correlate to the value of 6. All right, hopefully that's fairly straightforward. So And therefore, essentially, the integer 6 is also a rational number. Okay. And generally, let's note that the set of integers is subset to the set of rational numbers. All right. So far, so good. And then, of course, we might also observe that any decimal number that terminates is also a rational number. Okay, for instance, the following set of values. So, for example, you might have 0.01, which we may also express as the fraction 1, right? I'm just going to have some prefix zeros in that numerator. But 1 over 100, we're familiar with that one. And the same is true for 0.101, which we may also express. I'm just going to put some space between these. May also be expressed as the fraction 101 over 1000. And the same is true also for the terminating decimal 1.0001. Okay, that also may be expressed as the ratio of two integers, namely 10,001 over 10,000. Yeah, so as we can see, all of these terminating decimals may be expressed as the ratio of two integers. Great. All right, so let's talk about decimal transformations a little bit more. All right, and give sort of a rule. And we'll just give the sort of general rule for converting decimals, terminating decimals, that is, to a fraction. Okay, so to convert a terminating decimal to a fraction, simply count the number of decimal places, then write 1 followed by that number of zeros in the denominator, or for the denominator. All right, so pretty straightforward rule. All right, and then furthermore, any decimal that repeats may also be expressed as the ratio of two integers. For example, we might have the following repeating decimal. .0 and then 21 repeating, which of course equals 0.0212121 ad infinitum, right? Okay, so there's an example of a repeating decimal that, in fact, may be expressed as a ratio of two integers. And we'll work that out in just a moment. All right, so as we've just established, the sequence of integers under that replica bar there, I'm just going to stylize that key phrase. Okay, repeat indefinitely, right? And of course, in the case of 0.021 repeating, we place exactly 2 digits under the replica bar. Okay, so let's just work this out. So let's see if we can transform this repeating decimal that we have here to an integer, to a rational number. All right, so suppose we let x equal that very value. Okay, then we might write by substitution right? Okay, and now multiplying x by 100 is going to move that decimal place. Exactly 2 places to the right. Okay, let's see what that looks like. Okay, just like that. Now if we align these two results and subtract, we get the following. All right, and so then that's going to be 100x, which equals 2.1, 21, 21. which equals, and then subtracting rather, minus x, so then we're going to subtract x from both sides. Okay, and we'll get 0.02121. All right, very good. And now we may proceed as follows. Okay, so level lateral to the equal sign, we would get 99x end equation begin split and split. Okay. And dextrolateral to the equal sign, we get 2.1. And then on the next row, we would divide both sides by 99. Okay. Which, of course, is not a ratio of two integers. Okay, and we can rectify this by multiplying both sides of the numerator and denominator by 10. Okay, and that looks essentially like this. Begin equation. End equation. Begin split. End split. All right, and all that is left now, simplified the equation to x equals 21 over 99. And this last result may be further reduced by dividing both numerator and denominator by 3. Okay, which ultimately yields seven over 330. Once again, a ratio of two integers, and as such, a rational number. All right, And so what we'll do in the next video is look at a couple more examples of this. Okay. So as always, if you have any questions or comments regarding any of this material, feel free to leave a comment in the comment section below. If you like this video, give it a like and go ahead and subscribe, and I'll see you in the next one.